Welcome to today's challenge again. Look at this question before us here. How to solve x minus 1 equal to the cube root of x to the power of 3 minus 3x to the power of 2. Easy. So let's take our solution to this. So our solution. Alright. So the question is this. Here we have a radical and this is a cube root. So how do we eliminate this radical here? We just have to take the cube of both sides. So let's cube both sides of the equation. So this is going to give us our x minus 1 or to the power of 3. This is equal to the cube root of our x to the power of 3 minus 3x to the power of 2. So bracket, okay, put this all into our power of 3. This is easy, so this will go with this. Now go to the left with our x minus our 1 all to the power of 3. This is equal to x to the power of 3 minus 3x to the power of 2. Okay, we just have to expand this using the binomial expansion. Okay, so using the binomial expansion, the coefficient of this, we can use the Pascal diagram to get the coefficient of third power. So for the power of 0, we're going to have 1. At the power of 1, we're going to have here 1, 1 as the coefficient. And the power of 2, we're going to have here 1, 2, 1. That of 3, we're going to have 1, 3, 3, and 1. So we're dealing with this power here, the coefficient here. Okay, so if we expand this, it's going to give us here our x, which is the first term, it will be raised to what? The power of 3. So this is not going to be raised to power of 3 times. The next one is our 1 here, and our 1 is minus 1. Okay, so times minus 1 or to the power of 0. Clear? Yes. So we'll now take here plus the next one, the quantity is 3. So we're going to have here 3 into our x all to the power of 2 close bracket into minus 1 all to the power of 1. There plus the next one, the coefficient is 3. So we'll put 3 here first. Then now have here to the x all to the power of 1 into minus 1 all to the power of 2. Okay, then the next one we have plus coefficient is 1, so we're going to give us here our x all to the power of 0, then our minus 1 to the power of 3, everything equal to our expression here. So let's put it here, x to the power of 3 minus our 3x to the power of 2. Okay, so from here we're going to have our x to the power of 3 on the left here. Then here will give us minus 1. So this minus we times this plus to give us our minus. So I have here minus 3x or to the power of 2. Then here this will give us plus times this will give us plus 3x. Then this will give us minus. So minus times this will give us minus. And here we have 0 power of 0. So anything to the power of 0 will give us 1. So automatically this is going to give us minus 1, everything equal to x to the power of 3 minus 3x to the power of 2. So what we do next here now, we can collect like terms, all the terms having alphabets, that is variable, let's bring that to this side, and the ones that are constant, let's take that to the right hand side. So this is going to give us our x to the power of 3 minus 3x to the power of 2 plus 3x, then minus this process this side returns to minus minus x to the power of 3. Then this process to this side turns to plus 3x to the power of 2. Then everything equal to this comes to this side gives us positive 1. Alright, so let's look at terms that can cancel out here. Here we are having plus x to the power of 3 minus x to the power of 3. So this will go with this. minus 3x squared plus 3x squared. This again will go with this. Then we are now left with plus 3x. So we have a plus 3x equal to 1. So we divide by 3, divide by 3. This leaves. So we now have, therefore, our x is equal to 1 all over 3. Okay, so this is the value of x that will satisfy this original equation, this radical equation. But let's do a simple check if this will satisfy the original equation. Let's take our check. So our equation, we have x minus our 1 equal to cube root of our x to the power of 3 minus 3x to the power of 2. Okay, again, we want to do check. This is check, please. Okay, check here. So wherever we see our x, we put in this value. So we have here our 1 all over 3 minus 1. This is equal to the cube root of 1 all over 3 all to the power of 3, then minus 3 into our 1 all over 3, right, all to the power of 2. Easy. So this will give us, okay, let's handle this side of the equation. So here, LCM is just 3. So 3 into 3 will give us 1. 1 times 1 will give us 1. Then minus, here we have divisible 1. So 1 into 3 will give us 3. 1 times 3 will give us 3. Yeah. All right. So we take the cube root this side. So this will now give us here 1 to the power of 3 will give us 1 all over the 3 to the power of 3 will give us 27. Then minus, here we're going to have 3 times 1 all over 9. Okay, so if we carry out the subtraction here, we're going to have this to be minus 2 all over 3. This is equal to, here, 3 here, 1, 3 here, give us 3. So we now have here the cube root of our 1 all over 27, then minus 1 all over 3. So we can do a simple arithmetic here. Okay, so let's keep this side of the equation. This is going to give us equal to the cube root, okay, of the LCM of 27 and 3 is just 27. So we're going to have here 27. 27 to 27 will give us 1. 1 times 1 will give us 1 here. Minus 3 into 27 will give us 9. 9 times 4 will give us 9. Okay, so let's continue from here. Let's bring down our expression here. So we have minus 2 all over 3. This is equal to the cube root of, now if we subtract this from this is going to give us our minus 8 all over 27. All right, good. Now we can rewrite this expression we have in here now. This could be written as the cube root of minus 1 times the cube root of our 8, then all over the cube root of our 27. Okay, so this will now be equal to, what is the cube root of minus 1? This will give us minus 1 times the cube root of 8 will give us 2 all over the cube root of 27 will give us 3. And if we multiply, this will give us minus 2 all over 3. Let's bring this down here. If we decide to bring this down, this now implies that our minus 2 all over 3 is equal to minus 2 all over 3. Okay, so this shows that the answer to solve for our question is this x is equal to 1 all over 3 satisfy the original equation, which is this. So if you've learned something from this video tutorial, give the video a thumbs up. And if you are not clear with any of the steps applied in solving this solid here, then drop it in the comment section. Thanks for being there. Keep watching Online Maths TV. Better days ahead. Bye.